The Earth is spinning about 1,000 miles an hour, 1,041.6 for you technical folks, at the equator, but the Earth is slowing down. It actually is slowing down enough to create a problem. Every year to year and a half, they have to add a second to the clock because the Earth is slowing down. They call it a leap second. 1990, Pensacola News Journal said, we have to add a tick to the clock because Earth's rotation is slowing down. It says regular clocks use days as a measure, which are going longer by 1,000th of a second or more daily as Earth's rotation slows. 1992, Astronomy Magazine said, Earth's rotation is slowing down. June will be 1 second longer than normal. We will have a leap second. Leap second. Did you know we have a leap second about every year to year and a half? Because the Earth is slowing down. Now, kids, this is going to be complicated, so listen carefully. The Earth is spinning, but it is slowing down. So that means that it used to be going faster. How many can figure this out now with no help? Okay. Well, now, the Earth is only 6,000 years old. This is no problem. It was going a little faster when Adam was here. He wouldn't notice. He didn't have a watch anyway, as far as we know. But some of these guys want me to believe the Earth is billions of years old. Man, if you go back billions of years, the world was spinning real fast. Your days and nights would be pretty quick. Get up, go to bed, get up, go to bed, get up, go to bed. You never get nothing done. The centrifugal force would have been enormous. The winds would have been 5,000 miles an hour from the Coriolis effect. And you think dinosaurs lived 200 million years ago? Oh, I know what happened to them. They got blown off. No, they did not live 200 million years ago. Where did the energy come from? I mean, who bought the gas to run this machine? It takes energy to make something move. Where did the energy come from? The professor said, well, we don't know about that. I said, sir, could I ask you another question? He said, sure. What else would you like to know? Else? What do you mean else? You haven't told me nothing yet. I said, does Berkeley have a merry-go-round? How many of you know what a merry-go-round is? You go round, round, round till you puke, okay? He said, no, we don't have a merry-go-round at Berkeley. I said, you ought to get one, man. You could learn some good science on a merry-go-round. If you put some fourth graders on a merry-go-round, any fourth graders in here? Who's in fourth grade? All right, I like fourth graders. I spent the best 5 years of my life in the fourth grade. That was before they diagnosed ADD. We're going to put some fourth graders on the merry-go-round, and we're going to get the high school football team out there to get it spinning clockwise as fast as it will possibly go. Now, if you have a digital watch, you may not know what clockwise means. I'll tell you later, okay? We're going to spin the merry-go-round clockwise. The kids are going to go through 4 phases. They start off in phase 1. They're screaming at the football players, come on, let's go. Can't you go faster? Let's go. Move it, move it. You get up around 30 miles an hour. The kids enter phase 2, where they stop screaming. They just quietly concentrate on trying to hang on for dear life. You get up around 60 miles an hour, and the kids enter phase 3, where they start screaming again. But now they're screaming, stop, stop, please slow down. Don't stop, they'll keep going faster and faster. When you get to about 100 miles an hour, you should go into phase 4. That's where the kids begin to fly off the merry-go-round. Now, when this happens, you will notice an interesting phenomena of physics. If the merry-go-round is spinning clockwise, when the kid flies off, the kid will be spinning clockwise until he encounters resistance, like a tree or telephone pole. That's because of a law known as the conservation of angular momentum. You see, if a spinning object breaks apart in a frictionless environment, the fragments will always spin the same way because the outside's moving faster than the inside. People say, what if they hit each other? They can't hit each other. Drop a hand grenade off, let it explode. The longer you wait, the further apart the fragments become. How are they going to hit each other out there in the field someplace? Duh. We could talk all night about the conservation of angular momentum, but the professor said, yes, I'm familiar with the conservation laws. I said, well then good, sir. I have a question for you. If the universe began as a swirling dot, big bang, like you said, shouldn't everything be spinning the same way? He said, yes. I said, would you tell me why then that 2 and possibly 3 of the planets are spinning backwards? Can you tell me why 8 of the 91 known moons are spinning backwards? Will you tell me why 4 planets have moons going both directions at the same time? Can you explain to me why some whole galaxies are spinning backwards? He said, that's interesting. I said, no, sir, that's more than interesting. That's kind of hard on your Big Bang Theory. He said, why do you think they're going backwards? I was hoping he was going to ask that. I said, sir, it's very simple. You see, in the beginning, God created the heaven and the earth, and God did it that way on purpose, just to make the Big Bang Theory look stupid. Now, I do believe in the Big Bang, and I told him I believe in the Big Bang because the Bible teaches the Big Bang. It says the heavens shall pass away with a great noise. The original Greek, that's a Big Bang. See?